All right, picking up where we left off with part 3 of the January 2020 exam. Same situations with the directions. It's telling you to make sure you show all of your work, formulas, substitutions. If you're questioning whether you need to show your work, show it anyway. Check for rounding, check for all that good stuff. It even says right here, answers with no work can only receive 1 credit, and that's only if it's even right. So make sure you show all work to get all points possible. All right, number 33. Sonia is cutting wire to construct a mobile. She cuts 100 inches for the first piece, 80 inches for the second piece, and 64 inches for the third piece. Assuming this pattern continues, write an explicit equation for A sub n. Explicit is the opposite of recursive, where you only want one equation. And explicit also is given on the reference sheet. So the first thing I need to do is figure out what type of sequence this pattern is creating. So my first number is 100, my second number is 80, and my next number is 64. I have to figure out how I get from 100 to 80 and 80 to 64. So it's always easiest to check to see if it's an adding pattern first. This one's adding negative 20, but if I add negative 20 to 80, I don't get 64. So it's definitely not an adding pattern, which means it has to be a multiplying pattern. So to find out what you're multiplying 100 by to get to 80, you do 80 divided by 100. So I grab my calculator, get out of that graph. 80 divided by 100 is 0.8. So I'm multiplying by 0.8. Now I want to see if that works the whole way. Is 80 times 0.8 the next number? 64. Yes, it is. So that absolutely works. That means I'm multiplying by 0.8 each time. Times 0.8 times 0.8. Perfect. But what that mostly tells me is that this is a geometric sequence. So if I'm trying to write an explicit equation for AN, which is the length of inches in the nth piece, it's not asking me for the total amount of pieces. So this is definitely a sequence formula. I'm going to go down to my reference sheet, find geometric sequence, which is this guy right here, and I'm going to write that formula down. So I go back up. Look how far we have to go still. It's AN equals A1 times R to the n minus 1. The variables kind of stand for the same stuff that we talked about in the series formula, where A1 is the first term, R is what I'm multiplying by each time, and n is the number of terms. Now once again, just like the last one, it's asking me to write an equation for AN and the nth piece. That means I'm going to leave those pieces alone. AN is going to stay here, and so is n minus 1. That means I'm only plugging in for A1 and R. That's not so bad. I know what both of those are. A1 is the first term, which is right here. That's 100. Times R, which is what I'm multiplying by each time. That's the 0.8. To the n minus 1, this is my final answer. And I also used the correct notation. It said to use A, n, and n. So I'm good. Next, Sonia only has 40 feet of wire to use for the project, like the whole project, and wants to cut 20 pieces total for the mobile using her pattern. Will she have enough wire? So for this one, if she has 40 feet of wire to use, really think about what's happening here. I know it's kind of a weird situation, but for this one, she has 100 inches. For the next one, it's 80 inches. The next one is 64 inches, and so on. To find out the total amount of wire used, she has to add up all of the pieces. If you're adding up all of the pieces, you are working with a series. So I need my series formula again. So that was Sn equals, again, you would go to the reference sheet if you don't remember it, but it's A1 minus A1 times R to the n over 1 minus R. Given on the reference sheet, I'm just not scrolling all the way down again. It's the geometric series. Again, to repeat, the reason I know I need the series is because it wants to know how much pattern we're using total for the mobile, and that would be adding up all of my terms together. So now I'm going to plug all of this in. The 40 right now is not something I'm going to plug in. It's telling me how much she has, and it's asking me if she has enough. So what I'm trying to determine first is how much she's going to need, and then we'll find out if she has enough. So plugging in the information I know. I need the sum of all of the pieces. She wants to cut 20 pieces, so it's the sum of all 20. That means n is going to be 20. A1 is still 100, and my R is still being multiplied by 0.8 each time. So this is going to be 100 equals minus 100 times R is still 0.8. N is 20 because there's going to be 20 total pieces, and this is 1 minus 0.8 on the bottom. Now, I remind you, this on the bottom, when you plug in Yep, plug in the top first, I should say. Then when you go to divide by the bottom, this has to be one number. So I'm going to simplify that to 0.2, and I'm going to plug this all in. So it's 100 minus 100 times 0.8 to the 20th. That'll get me 98.8470789. Wow, what just happened there? My pen's been having a rough day. I think it's tired. 84954. Actually, I don't know what the battery's at. I should probably check that. Okay, when I divide that now by the one number on the bottom, this is what I get. So that means the sum of all 20 pieces, S of 20, is 494.23539247. Now remember, there's tricks. There are always tricks on the exam. You have to think about what we were working with before. This was 100 inches, 80 inches, 64 inches. I just added together all of the inches, and that means all of the pieces are going to have a total of this many inches. Now it's telling me that she has 40 feet of wire. To figure out if she has enough, I need to convert that to inches. How do I convert 40 feet to inches? You have to ask yourself how many inches are in 1 foot. There are 12 inches in 1 foot, so I have to multiply those together. So I do 40 times 12, and I get 480. That means she has 480 inches of wire. So she has 480 inches of wire. She needs 494 inches of wire. So then think about it. If she has 480 and she needs 494, does she have enough? No. She needs about 494 inches. She only has 480 inches. Boom. Perfect. Next. Graph. Another graph. Oh, perfect. Love graphs. Now this is a log graph. It says graph the following function on the axis below, and there's a couple follow-up questions, but we'll get to those after we graph it. You need to know how to plug this in your calculator. To my TI-84 peeps, you have to hit math, alpha, math, and it'll set up the log with a base for you. You can't just use this log button next to the 7. You can't just use that log button because that is log base 10. This is a log base 3. So to my TI-83 people, you have to type it in as the change of base. So you type it in as the log of what you're taking the log of, which is 2 minus x, divided by the log of the base. You just have to remember it. Change of base. Okay, so whichever calculator you have, please plug it in accordingly in your calculator. Don't know if mine will let me. It will, thank goodness. So the 3 goes down there. And then 2 minus x, just so my 83 people can see. You're going to hit the log button of 2 minus x. But because it's base 3, you are then going to divide by the log of 3. So those are the two different ways to plug it in. Again, depending on your calculator, just make sure you have one of those. And then you can hit graph to see what it's supposed to look like. Please ignore my squares on there, by the way. They are just giving me a couple of values. It's just the app that I'm using, so you should not have those. Some of your calculators will also have the asymptote drawn in for you. We'll talk about what that is in a little bit, but it should be going through the 2. So again, we'll talk about that in a minute, but for right now, I need to graph this. So I'm going to clear one of these out just so my table's not ugly. And I'm going to go to my table. So look at all those errors. I could scroll forever. They would always have errors. We'll talk about that in a sec. But for now, I just need to plot points that are plottable. So can't plot that negative 25. All these other ones are kind of yucky. So the first nice point is going to be negative 7, 2. The next one is negative 1, 1. And then after that is 1, 0. So you can plot a couple extra points just as reference points. Like for example, here's some of my extra points. Maybe negative 2, 1.26. And then I'll also throw in that 0 as 0.6. I know they're not ideal to plot yucky decimals, but it's not so bad. It's a graphing question on the Regents. They're never that bad. 1, 2, 3, 4, 5, 6, 7 to the left and up 2 is going to be here. Negative 1, 1 is here. and then 1, 0 is right here. And I'll plot those other couple points. So -2 was at 1.26, so about right there. Oops, no. About right there. There we go. And 0.6 is about right here. So it just kind of helps you form that arch. Now, before you go and connect these and do something like crazy like that, no. Hit the graph button and remind yourself what it's supposed to look like. It has a abrupt drop at that value of 2. You can see that it happens at 2 because if I go back to my table, at 2 there's an error. That means your graph never hits an x value of 2. Again, we'll talk about it in a second, but as I go to connect these, I never want my graph to hit the x value of 2 because there's an error there. So I'm just going to slowly get close to the 2, but never hit it. So this right here had an error on the graph. What that means is that the graph gets really, really close to 2, like literally 1.9999999999999, but it never actually ever hits 2. That's why there's an error on every value after the 2 because the graph does not exist over here. That is the definition of an asymptote. There is no graph past that x value of 2, so that means that your asymptote is at x equals 2. So we already answered something just by graphing it, which is awesome, but you need to know what an asymptote is. So if you don't have that memorized, get on that. All right, now the part before it was the domain. Remember, the domain is the interval of x values. So I'm trying to figure out the x values that this graph consumes. So it stops at x equals 2. It never hits x equals 2, and it goes to the left forever. So my graph starts, because it goes left forever, starts at -infinity and goes all the way to 2. Now, you can either use a bracket here or parentheses, depending on whether or not the 2 is included. The whole point about this graph is that the asymptote is at x equals 2, so the graph does not exist at 2. That means I'm going to use parentheses. That's one way to write the domain. That's the way that I believe we wrote it most in class. Another way that you can write this is x is less than 2. It doesn't specifically say in interval notation or in set notation. So you can write the domain however you'd like. We're used to intervals, so I figure most of you would probably do that. But x is less than 2 also works because the graph exists for all values that are less than 2. It starts at 2 and then goes left forever from there. All right, question number 35. Algebraically solve the following system of equations. First of all, it says algebraically. You have to do it algebraically, which means show your algebra. So that's thing number 1. Number 2 is a system. If you're solving a system, it means you have to solve for all of the variables in the system. So for this one, I'm going to be solving for x and for y. And for this one, it's a system of 2 equations because I only have 2 equations here. So when you first go to tackle this question, like I said, there's 2 variables. There's an x and a y in both of them. You can't just tackle that right away with 2 variables in it because you can't really solve for x if there's a y in it. You can't solve for y if there's an x in it. So what we're going to have to do is something called substitution. I'm going to have to plug one of the equations into the other one. And to do that, I'm going to have to solve for one of the variables. So I'm hoping it's pretty obvious that I'm not going to want to solve this one for a variable because that is a disaster of an equation. Hopefully we're recognizing it's a circle. If not, we need to study our circle formula. But anyway, that's a little side note. This bottom one, I'm going to have to solve this bottom equation for one of the variables and then plug it into the other equation. So what I mean by that is I need to solve this for one of the variables. It doesn't matter which one. I'm going to solve it for y so that I can get it in terms of x, and then my equation will just have x's in it. You'll see as we get there. So if I solve this for y, I need to get the x to the other side. So I'm going to subtract it over since it's positive. And I'm going to add that -1 over. So these are both going to cancel, and I'll end up with y equals a negative x plus 1. The reason this benefits me is because now I know what y is equal to, and I have a y equals in this equation up here. So I'm going to take what y is equal to, which is negative x plus 1. Y and negative x plus 1 are the same thing. They're equal to each other. So I can now take this and plug it into y in this equation. So when I rewrite my top equation by replacing the y, it'll be x minus 2 squared still, plus in place of y is going to be negative x plus 1, and then I bring down the rest of this equation. So the -3 comes down, the squared comes down, and the equals 16 comes down. Here's why you wanted to do that. If you look at this equation that I have now, Notice there's only one variable in it. I only have x's. So now I'm good to just tackle this equation and solve it from here. So first thing I notice is this. Kind of ugly, and I can simplify it. This is actually negative x minus 2 when you combine like terms, because negative 1 plus 3 is a minus 2. Next thing I notice is that these are being squared. Squared means write them out twice. So this is x minus 2 times x minus 2 plus this is negative x minus 2 times negative x minus 2, and the equals 16 comes down. Now I have a lot of multiplying to do. Here I go. X times x is x squared. I'm going to do that shortcut for the next step. X times negative 2 is minus 2x. Negative 2 times x is another minus 2x. When I combine them, I get minus 4x. And then negative 2 times negative 2 is a plus 4. Next, bring down that plus sign. So I'm going to bring down the plus. Then when I multiply this out, negative x times negative x is an x squared. Then, here I go with the shortcut again. A negative x times a negative 2 is a positive 2x. And then here, same thing, negative 2 times negative x is a positive 2x. When I add those, I get a plus 4x. And then negative 2 times negative 2 is a plus 4. And that equals 16. So now I'm going to combine my like terms. I have an x squared and an x squared. That'll get me 2x squared. When I combine my x's, a negative 4x and a positive 4x cancel each other out, so those are gone. And then a positive 4 and a positive 4 is going to be a plus 8. So that equals 16. Okay. There are two different ways that you can tackle this. If you want to factor it, because there's an x squared in it, you would get it equal to 0, and then you'd have to do a GCF and factor it. What I'm going to do, I'll actually show you both ways. So let's do that way first. If you wanted to factor this, you would subtract the 16 from both sides first. When I subtract 16 from 8, I get a minus 8. Okay. When I GCF a 2 out, I'm going to take out the 2 in front, and that would leave me with an x squared minus 4. When you completely factor this, that can be DOPS, and I'll be left with an x plus 2 and an x minus 2. Wow, that's very sloppy. I'm clearly getting tired here. Okay, now I'm going to tee this up. Over here, 2 equals 0, nothing happens. Here, x plus 2 equals 0 will end up getting me a negative 2. And here, x minus 2 equals 0 will get me a positive 2. So I get two x values, a negative 2 and a positive 2. That's one way to solve it, is by factoring. The other way is to now just get the x squared by itself. So to do that, I'd have to subtract the 8 from both sides. I get 2x squared equals 8. Divide by 2, and I get x squared equals 4. And then to get rid of the squared, you'd have to take the square root. The reason, I mean, this is definitely the shorter way, but the reason it might be frowned upon, depending on, what you remember and what you don't, is that when you take the square root, you need that plus or minus in front. So this means x equals negative 2 and x equals positive 2, but you have to remember the plus and minus. If you don't think you can remember the plus and minus, factor it. Works every time. It'll kind of like take care of the plus and minus for you. Okay, so you don't have to do both. This is a one or the other situation for this step. Now I'm going to come back with my two x values. I have an x equals negative 2 and an x equals positive 2. Now remember from the beginning, I have to solve the system, which means I have to solve for x and y. So what I'm going to do now is I'm going to use this equation that I found for y equals negative x plus 1, and plug in my x values. So first for a negative 2, I'm going to plug it in as y equals, the equation says negative, and then I'm plugging in a negative 2. So that's going to be a positive 2 plus 1, so I get y equals 3. That means one of my total answers is negative 2, 3. The next one is y equals, the negative from my equation comes down, and then I plug in 2 plus 1, and negative 2 plus 1 is a negative 1, so my other answer is 2, negative 1. And those are my two answers, negative 2, 3, and 2, negative 1. Perfect. Next. 36. The table below gives air pressures in something at selected altitudes above sea level measured in kilometers. So it tells me that x represents the altitude and y represents the air pressure. That's going to be very important later. But for right now, I'm going to read the next part. It says, write an exponential regression equation that models these data rounding all values to the nearest thousandth. Exponential regression is not so bad as long as you remember the steps for exponential regression. If we don't, this is going to be very difficult because you have to do it completely on your calculator. So to do regression, you have to press the stat button. So I'm going to press stat, and then you press edit. You then have to clear out your lists. I forgot mine's different. So you're going to clear out the list that you have in there by highlighting over L1, pressing clear enter, highlighting over L2 and pressing clear enter. I have to go through and actually delete my values, but you do not have to do that. So again, highlight over L1, clear enter, highlight over L2, hit clear enter. Now your X values get typed into L1, your Y values get typed into L2. So here I go. L1 is 0, 1, 2, 3, 4, 5. Next 101, 90, 79, 70, 62, 54. So I remember how to do exponential regression. I'm pumped that this is even on the exam because I just think that it's so easy, and then I accidentally type in a number wrong. Do you know how devastated I would be? Please, if you have a question like this on the exam, double check that you typed all of your numbers in correctly. That's what I just did. Maybe you typed in a 100 instead of a 101. Your whole answer would be wrong, and that would be miserable. So double check, and now we're on to the next step. Now it told me to do exponential regression. So my next step to find exponential regression is to press stat and go over to calc. Now, all the different regressions are here. Linear regression, quadratic regression, cubic regression. You're going to pick the one that it wants. This one's exponential regression, which is choice 0. And then you just keep pressing enter until this screen comes up. You may or may not have the R values. You do not need them for this example. So because everything was done entirely on the calculator, and I cannot stress this enough, you show your work by copying the calculator screen. So y equals a times b to the x, and then a equals 101 point blah blah blah. Okay. If you copy R, there's no harm, no anything. You just need to know that it has nothing to do with your exponential regression equation. It tells you the strength of the data. So an R value of negative 0.999 is a very strong exponential relationship. But again, not super relevant to this question. It just wants the equation. So what I just copied from the calculator is all the work that needs to be shown. It is not my answer. What I need to do now is round everything to first the nearest thousandth, which is 3 places after the decimal point. This one is going to be 101 point. If I go to the thousandth, that's right here, but the 8 will bump that up, so it's 523. And when I round this to the thousandth, I'll get 0.88. Again, I'm stopping here, but that 6 will bump that up to a 3, so 0.883. Still not my final answer because I haven't written the equation. The answer is going to be those red rounded values plugged into your given format, that highlighted piece right there. So my answer is going to be y equals, I plug in my a, which was 101.523, times my b, which is 0.883, raised to the x. There's my equation. Now, this is just a helpful hint for future examples. Sometimes this will be labeled like M and T. If they're labeled different letters, you have to use those letters. We could use Y and X for this one because those are the letters that were given in the problem. If it indicates different letters, you have to make sure you use those letters instead. Okay. Now part B says use this equation to algebraically determine the altitude. If it's asking me to determine the altitude, you guys think this through. If I have to find altitude, altitude is X. This is just saying find or solve for X. To the nearest hundredth of a kilometer when the air pressure is 29. Air pressure is Y, so it's telling me Y is 29 and find X. So just take their code and their variables and plug in what needs to be plugged in, where it needs to be plugged in. If you plug 29 in for X, you're going to get the answer wrong because it's telling you that it's your Y value. So 29 is going to get plugged in for Y. Everything else is just going to come down. Now immediately I'm excited because I see X in the exponent. What does that mean? It means I need to use logs. Woohoo! So to use logs, I have to get what's being raised to the variable by itself first. So my first step is to get rid of that 101. Since it's being multiplied here, I'm going to divide by the 101.523. Divided by 101.523. So 29 divided by 101.523. And I get a long decimal. You have to use the whole decimal. You cannot round until your last step. Perfect. Okay, now that I got that boxed in piece from the last step by itself, I'm able to use logs now. So to get that x out of the exponent, I'm going to write the word log on both sides. Now when I write the word log on this side, the whole point in using logs is because it takes that exponent and it brings it to the front. So my x is going to end up there by a log rule, the log exponent rule. Now to get x by itself, right now it's being multiplied by the log of 0.883. So to get rid of it and to get x by itself, I'm going to divide both sides by the log of 0.883. So in my calculator, I take the log of that number divided by the log of 0.883. Should I write out my whole answer as a decimal? Yes, you absolutely should, because why not? We have no reason not to. Show all of your work at all times. Perfect. If you need more time, pause the video. This one's telling me to round to the nearest hundredth. Hundredth is 2 places after the decimal point, so I'm going to stop here, but that 9 is going to bump this up. So it's 10.07, and it was asking me to find of a kilometer, so this is going to be km. 10.07 kilometers. Don't believe any points were taken off on this exam for labeling, but label just in case. You never know. All right, now the dreaded part 4. It is 6 points, so it's going to be a beast. Here we go. Sarah is fighting a sinus infection. Her doctor prescribed a nasal spray and an antibiotic to fight the infection. The active ingredients in milligrams remaining in the bloodstream from the nasal spray N of T and the antibiotic A of T are modeled in the function below, where T is the time in hours since the medications were taken. So we have 2 equations again. Part A here, I know they're not labeled, but this first part says determine which drug is made with a greater initial amount of active ingredient. I need you guys to think logically for this. T represents the time in hours. So T is hours, and it wants to know which one has the greater initial or starting amount. What would the time be if we are just starting? T is going to be 0. It's not a super challenging question. You just have to really think about that. If you're just starting and T represents your time, that means T is just going to be 0. So it wants to know which drug, so I'm going to have to plug N0 into both of these, had a greater initial amount of the active ingredient. So I'm going to do N of 0, and I'm going to do A of 0, and then compare the two. So N of 0, when I plug in 0 for T, it'll be 0 plus 1 over 0 plus 5 plus 18 over 0 squared plus 8 times 0 plus 15. So many zeros. Then over here is 9 over 0 plus 3. I'm going to do this one first because it's a lot easier. This is 9 over 3, which is 3. Okay, so I know that that one has 3 in it to start. Now over here, yuck. 0 plus 1 is 1 over 0 plus 5, which is 5. And this is 18 over, and I'm just going to plug that into my calculator because, again, work smarter, not harder. Actually, no, I'm not going to plug it into my calculator because I just used my brain. 0 squared is 0, plus 8 times 0, which is 0, plus 15 is going to be 15. Now I'm going to plug it into my calculator. So it is 1/5 plus 18 divided by 15. I get 1.4. So N of 0 is 1.4, A of 0 is 3. So it's asking which drug had the greater initial amount. It's definitely the 3 because 3 is bigger than 1.4, but I have to answer the question. So we need to know what the A of T represented. The antibiotic was A of T. So my answer is going to be the antibiotic. That had more of the active ingredient initially than the other one, which was the nasal spray. Boom. Next part. Sarah's doctor told her to take both drugs at the same time. Determine algebraically, so I have to show my algebra, the number of hours after taking the medications when both medications will have the same amount of the active ingredient remaining in her bloodstream. So since both of the equations represent, let me go back and read. So both the equations represent the active ingredients remaining in the bloodstream. This question is asking me to find out when both medications will have the same amount of active ingredients remaining in the bloodstream. If this equation represents the nasal spray, This one represents the antibiotics, and I have to find out when they're the same. I have to set them equal to each other, as ugly as that initially looks right now. So I'm going to start by setting them equal to each other. T plus 1 over T plus 5 plus 18 over T squared plus 8T plus 15. Set it equal to the other one, which was 9 over T plus 3. Okay. To find out where they have the same amount, I'm setting them equal to each other. Now again, key word is when. If I'm trying to find out when, I have to solve for T. T was the time. All right, fractional equation. I remember this rule. To solve a fractional equation, which just means it's an equation with fractions in it, I have to multiply all fractions by the LCD. So I'm going to move this down a little bit. I wish you guys could actually do that on your exams. But to multiply by the LCD, I first need to find the LCD, and sometimes that requires some extra steps. So the overall idea of LCD is it takes a little bit of all of the denominators. This one has T plus 5, this one's blah, and this one's T plus 3. I don't want all of that. That is a nightmare. If anything is factorable, you want to factor it first. If I factored this that I just highlighted in green, sorry, it is an easy trinomial, so I need to figure out what multiplies to 15 and adds to 8. It's going to be 5 and 3. Fancy that. This is T plus 5, T plus 3, and I'm just going to replace this with that. So now looking at all of the denominators, I have T plus 5 in 2 of them and T plus 3 in both of them, or I'm sorry, in 2 of them. So my overall LCD is T plus 5 and T plus 3. Now I have to multiply all of my fractions by that. This is the stuff that we kind of hated during class, but write it, please. I cannot tell you how many times people think that they can do it without it, and then it just makes it messy and makes mistakes. Just write it out. It takes a couple of seconds. Okay, T plus 5, T plus 3. The reason we multiply by the entire LCD is because I don't want fractions. We're going to completely get rid of them now. So this denominator is going to cancel with this. These are both going to cancel with both of these, and this is going to cancel with this. Now, I was very overdramatic with how I canceled these out. You want whoever's grading your Regents exam to be able to read what you originally had written down, so cross them out lightly, like so. So it's still readable, but so that you can tell that it's still crossed off. So it's crossed off, oopsie, it's crossed off, it's gone, but the grader can still see your work. So the T plus 5's cancel. Look what's left in this first bit. T plus 1 and T plus 3. So I'm going to write T plus 1, T plus 3. I use multiplication because that's what I was doing this whole time, is multiplying by the LCD. The plus comes down, everything canceled here, so it's just 18. The equals comes down, and then this is what's left. And this one, it's a 9 times T plus 5. And now I'm off to simplify this. First, multiply this out. I get T squared plus, I'm just going to do it, 3T plus 1T plus 3. The plus 18 comes down, and I'm going to distribute this through as well. I get 9T plus 45. Now I have a T squared and a T, which means I'm going to have to move these over. So minus 9T minus 45 minus 9T minus 45. Now combining all of these is going to be a good time. The T squared has nothing to combine to, so that just comes down. I have a positive 3T plus 1T minus 9T. I'm going to combine all of those. 3 plus 1 is 4, minus 9 is a negative 5T. Now same kind of situation here. I have a positive 3 plus 18 minus 45. So 3 plus 18 is 21 minus 45 gets me a negative 24. So I get minus 24, whoopsie, and that equals 0. Okay, now that I got it equal to 0, I'm ready to, it's like in its factored setup, I'm just going to factor it. So now is when I factor. The two numbers that multiply to negative 24 that add to the middle number, which is negative 5, is going to be a negative 8 and 3. So this is T minus 8 and T plus 3 equals 0. So I tee it up. T minus 8 equals 0. T plus 3 equals 0. I get T equals negative 3 and T equals 8. Now, there are two different things to consider in this example. First of all, T represents time. One of these is an issue right away. I can't have negative time, so I'm going to reject this answer just based on the word problem. But if there was no word problem and there was no context to this, you still have to check. It's one of those situations where it's not like optional and I'm telling you should check, like you have to, because there's going to be rejected answers. Now, when you check with a fractional equation, you just have to plug it into the denominator. So when we were doing these in class, we were writing off to the side what x could not equal. For this one, it's not going to be an x, it's going to be a t. But for this one, t right here cannot equal a -3, and t right here cannot equal a -5. So those are my two no-no values. This one says t is -3. I immediately have to reject that. So the -3 cannot be an answer, which means my only answer is 8. And 8 represents 8 hours. So 8 hours is my answer. All right, if you guys that was the end of it, right? Woo, we made it through an exam. Woo-hoo! If you guys have questions, please reach out.